All right. Good morning, everyone, or good afternoon. Welcome to Pulse Canada's Pea Protein Micro-Summit. So I'm Janelle Carlin. I'm going to be moderating as well as presenting here today. I'm the Director of Quality Science and Food Innovation at Pulse Canada. So it's my pleasure to be joined here today by Dr. James McKendry and Dr. Jacob Smith, who will be joining me in presenting some very interesting new research on pea protein and muscle growth and innovation insights from the patent landscape. So welcome to both of you, and then excited to hear from you both later. For today, I can just take a look here at the schedule of events and timeline. I'm going to be starting off with just a quick presentation to set the stage. But in terms of housekeeping items, just a reminder that the recording will be circulated to everyone who registered following the webinar. You can ask questions throughout the series of presentations. So that is on the right-hand side of your screen. There's a Q&A box that's separate from the chat box. So it's a distinct section. And any question that has been previously posed by another attendee, you are also able to upvote that. So you can prioritize a question that is of interest to you. We also have a new resource hub. So you can see that on the left-hand menu on your screen. And there you'll find a series of different resources. So that'll include reports for some of the content that is presented here today. You can also find the recording for today's webinar there, and then some other external resources that are related to pea protein. So just to kick things off, I'm going to set the stage a little bit on why pea protein. So globally, protein ingredient demand is rising, and this is both animal-derived and non-animal-derived sources of protein. So not particularly an emphasis in terms of the volume of growth on one versus the other, but all of them remain critically important around the world. This slide highlights a specific breakdown for the US demand in particular, where you can see that animal demand still remains a little bit more prevalent, but the percentage of consumers wanting plant-based is quite high, irregardless of that animal-based protein consumption. So both of these protein sources and protein types are growing, and it really points that there's room for innovation. In terms of trends for reformulations, proteins are being found in almost every type or product format, taking advantage of clean label trends, free from, and plus claims. So, really leveraging some of those nutrient density attributes that are being demanded of consumers. So, you can see the shift in how prevalent protein content claims are in the marketplace. On the top hand right side of your screen, you'll note that 42% of US protein, US product launches contained an added protein content claim. And this has grown from 5 years ago where that was only 28% that included that added protein content claim. So that's new product launches in the US. And globally, the trend for protein is still prevalent, even though it is a little bit more dominant in some of those Western markets at 7.4% of new product launches containing an added protein content claim. In terms of where pea protein fits in, so this is taking a look at those non-animal sources of protein where historically soy, wheat, and maize have been the top three and predominant sources. Where if you look back at about 2014, pea protein accounted for only 3% of total volume demand for plant protein sources. All the way through to 2025, it now accounts for 10% of the demand. Pea protein has since become a more common and mainstream ingredient and is now emerging as one of the top three based on the past 7 years of new product innovation data that has been sourced from Mintel. So US customers are already familiar with pea protein. There is growing awareness and acceptance. So people are very curious about it. Based on a consumer insight study that Pulse Canada commissioned, it indicated that overall there's a lot of positive associations with pea protein from consumers. So they are relating that with claims or attributes supported health and wellness associations. So when asked about why they were consuming pea protein or why they might be considered to consume pea protein, there were drivers like it contributes protein to the diet, it helps to promote stable blood sugar levels, satisfies hunger, makes you feel good, is environmentally friendly. So there's a lot of positive associations that are raising that awareness to that acceptance profile in the consumer landscape. So this slide here maps out the future consumption trends for pea protein, where on the x-axis, you can, when they were asked about what types of products that they actually consume pea protein in, you can see that the consumption volumes from left to right is growing. And then on the y-axis, it maps out consideration volume. So higher up on that y-axis will indicate that there's a high consideration for consumers to consider consuming pea protein in those particular product types. And essentially what this graph is showing in particular along that dark shaded line is that those would be a strong relationship between usage and consideration. So there's generally a very good adoption of pea protein. As you look to the types of products that are popping up more on the left-hand side of this chart, to the left of that dark shaded line, that's where consumers have indicated that they would strongly consider consuming pea protein. However, the consumption and actual utilization hasn't necessarily matched that yet. So that could be because there's a lack of products, or maybe the products aren't necessarily meeting some of their expectations, but presents opportunities for the food sector in terms of innovation. So particular product categories that I'll call out there that demonstrate a lot of promise for innovation would include that bakery category. So things like breads and flatbreads, looking at burger patties, meatballs, as well as pasta. Taking a look at actual innovations that have been occurring over the past several years that are implementing pea protein, historically, meat substitutes and plant-based dairy have been the most predominant sources of categories which are leveraging pea protein, where we are seeing a little bit of a slowdown in terms of new products that are being launched in those categories, where nutritional drinks and snack bars have been slowly rising. You can also see that the baked goods category here, again, so similar to that previous slide that we saw, are really demonstrating a lot of promise. So bread and baked goods and the cookies and snacks category here, you can see have been slowly on the rise over the past several years. Lastly, this is just showing some examples of category penetration for pea protein. So across the different types of end use categories, you can see examples of products that are using pea protein, as well as on the bottom, that's looking at the penetration of pea protein in the category. So for every 100 new product launches in that category, what percentage of them contain pea protein in that iteration? So there's pretty high penetration in certain categories like the alternative meat sector and nutritional drinks category. And some of the other categories where we see a lot of promise, not necessarily as high of penetration, but the size of the category is very large. So still presents quite a good opportunity for innovation. So, in summary, just to set the stage here today, we are seeing a growing market for alternative proteins. Specifically, when we're talking about pea protein, there is a positive and familiarity when it comes to consumer perceptions related to pea protein, where they are a very versatile ingredient. So we see them being used across a whole range of different end use categories, and they're multifunctional. So they're added not only for their nutritional composition, but also for specific functionalities that they might bring to the table. And we'll highlight some of those here later today. And overall, there's an expanding market when it comes to looking at pea protein. So with that, I'm going to pass things off to our first speaker. So here we have Dr. James McHenry, and he's going to be presenting on some research that he's conducted over the years that's looking at pea protein versus whey for muscle protein synthesis in aging adults. So thanks, James, for joining us.
Thank you very much for having me. It's an absolute honor to be invited to speak at this webinar today, so I really appreciate the opportunity. I'd first like to start by acknowledging that where I am currently presenting to you from, the University of British Columbia, resides on the ancestral and unceded territory of the Musqueam people. And the land on which I gather today is the unceded territory of the Silix Okanagan peoples as well. So I imagine that when many of you think of aging, this image of an older individual helped into and out of their chair, going about their day with some form of walking aid, will be the archetypal image that springs to mind. Now, unfortunately, it's clear that in Canada, we're heading into uncharted territories with our aging population, and it's projected to continue expanding. The number of Canadians aged 65 and older is projected to increase by 68% over the next 20 years or so, with the oldest old individuals, the over 75-year-old, projected to grow at an even faster rate. So in BC by 2040, 25% of the population, or 1.6 million people, will be over 65. So, however, the problem is not that we're aging per se, it's that we're aging poorly, burdened by disease and disability in larger proportions of our later years. And this is likely creating a healthcare and financial crisis equivalent in scale to global warming. So the focus of age-related science should be to extend the health span of our aging populations and compress those years of morbidity and mortality much closer to the end of natural life. Now, one of the primary reasons we see for this decline in health status as we age is that skeletal muscle mass and strength decline at a rate of approximately 1% and 3% per year, respectively. Typically, older individuals cross a threshold of physical dependency around 80 years of age, but it's not uncommon for older individuals to experience an acute muscle disuse event, such as a broken limb, an acute illness, or even a short hospital stay that increases one's sedentary time or reduces their habitual physical activity. And this can lead to a precipitous decline in muscle mass. And if this goes unchecked, older individuals cross this threshold of physical dependency much earlier, drastically worsening the quality of life that they experience, increasing the risk of non-communicable diseases. And unfortunately, unlike younger individuals, older adults don't really bounce back with the same oomph that younger individuals do. I'm sure many of you are aware there are a whole host of things that tend to go wrong as we get older. On this slide, you can see some of the kind of cellular events that tend to drive skeletal muscle loss with aging. This could be impairments in mitochondrial function or changes in the hormonal profile as older females progress through menopause, or even simply not using your muscles as much can lead to neuromuscular alterations. And all of these are exacerbated by environmental or lifestyle factors such as poor diet, smoking, obesity, those kind of things. Ultimately, they all contribute to disturbing this net protein balance, which is what dictates skeletal muscle mass, and they tip it in favor of loss. So the amount of muscle you have is dictated by these two processes, muscle protein synthesis and muscle protein breakdown. And you can see the relative rates on the y-axis and the time on the x-axis over the course of the day. Now, in an older individual who consumes a little bit of protein with their breakfast, you can see a small increase in muscle protein synthesis and a bit of a suppression in muscle protein breakdown. And perhaps they consume a little bit more protein at lunch, slightly bigger rise, slightly bigger suppression. And if you're anything like my parents, they consume most of their protein with their evening meal, and they get a big increase in this muscle protein synthetic response. And this is the process that drives muscle building and a small suppression again. Now, in young individuals whose muscles remain sensitive to the protein that we consume, they require a relatively modest amount of protein, such that they almost hit their threshold for maximizing this muscle building response with every meal, but certainly with lunch and way surpassing that with dinner. However, an older individual, as a result of a phenomenon called anabolic resistance, they need a much larger dose of protein to achieve this maximal stimulation of muscle building. So for an 85 kilogram older male or female, a young individual would require around 20 grams of protein per serving to hit this response, but an older individual would require almost double that, so up to 35 to 40 grams of protein to achieve the same benefits for muscle building. And this means that over time, their negative net protein balance will drive a loss of skeletal muscle mass. And here are some nice data from Dan Moore, who compiled the muscle building response on the y-axis and the relative intake of protein on the x-axis in grams per kilogram of body mass per day. And you can see quite nicely that up to a point, around 0.24 grams per kilogram of body mass, younger individuals really max out this muscle building response. However, older individuals see a rightward shift of this slope, and they require around 0.4 grams per kilogram of body mass. So they require much, much more protein to get the same muscle sparing effects. However, that's not the only way in which we can combat muscle anabolic resistance with aging. The most effective strategies generally come from lifestyle modifications, such as exercise and tinkering in other ways with protein nutrition. So what we can do is, I've talked a little bit about the per meal dose that we provide, but also the total amount that we consume throughout the day is a really useful target. The distribution of how we space out those protein consuming events throughout the day, whether it's all in one meal or whether people adopt a more moderate but repeated pattern. But particularly relevant for today's topic is this ongoing debate of whether animal or plant-based protein sources are superior than one another to drive increases in muscle protein synthesis and ultimately contribute, hopefully, to the maintenance of skeletal muscle as we age. So the older individuals can maintain their habitual levels of physical activity and do the things that are important to them, like pick up their grandkids and things like that. So, in order to interrogate this question, we conducted a randomized, placebo-controlled trial with two separate phases. A control phase where we fed older individuals their protein intake in line with current recommendations of 0.8 grams per kilogram of body mass per day. And then a supplemental phase where we provided 25 grams of protein at breakfast and lunch. And the only difference between the three conditions was the source of this additional protein. So participants were instructed to maintain the same activity. We controlled everything about their diet. So it was a very well controlled study. And we hypothesized that whey protein, commonly known as the kind of gold standard for muscle building, would be superior to pea protein, and both of which would be superior to collagen protein, which, if for those of you that may not be aware, collagen protein is a protein source that is heavily marketed towards older individuals to help promote muscle building, but in most previous studies shows to be of little benefit for maintaining skeletal muscle. So we hypothesized that whey and pea would be better than collagen, but whey would be superior to the pea protein. To give you a bit of a detailed breakdown of how we conducted the study, at baseline, we took measures of body composition and physical function. We then provided them with this heavy water, which is our stable isotope tracer, which enables us to measure muscle building over several days or weeks. And we collected a baseline blood sample. We then, on the following day, collected a single muscle biopsy sample, urine samples, and we sent the participants away with all of their meals for the next week at this 0.8 grams of protein per kilogram of body mass per day. The week following that, participants returned to the lab. We took another muscle biopsy, so that enables us to measure muscle building between these two periods, which we control protein at the RDA. Then the following week, the only difference was that we provided these older individuals with this protein supplement twice daily at their breakfast and lunch meals. And finally, 2 weeks following their initial visit, participants returned for a final muscle biopsy and some final blood and urine samples. You can see, try not to draw, this is too much data for you to pay attention to all of it. So you can see quite nicely the similar age of the participants that we recruited and also similar body composition. So it wasn't that one group was drastically different from the other. And towards the bottom, you can see that they're similar in metabolic health, such that their fasting glucose and insulin was very similar among participants. And here we have their dietary intake for all of the groups. And you can see quite nicely during the control phase, we got everyone pretty much exactly at 0.8 grams of protein per kilogram of body mass, and providing them with this dietary supplement increased their protein intake throughout the day by approximately 15%. So it got their intake to 1.3 grams per kilogram of body mass per day. And I think that lines up quite nicely with the recent changes in the US dietary guidelines, at least. But other than that, very little differences in terms of their dietary intake. So our intervention was successful. Physical activity data here, you can see that these are non-exercising but relatively habitually active older individuals. So they're accumulating a good number of steps per day, but they weren't engaging in strenuous physical activity. So this is a diet-only effect, not the response of increasing their muscle building activities or something. So here is what I want to draw all of your attention to. You can see the muscle building response on the y-axis and the two separate phases on the x-axis. Now at baseline, in the control phase, where participants were provided with their protein at the recommended dietary allowance, you can see quite nicely there are no differences between the groups, which is what we would have hoped. However, when we supplemented the groups the following week, the older individuals consuming whey and pea protein saw an increase in the rate at which they build muscle, and the collagen protein group did not see the same increase. So to me, that indicates a few things. Firstly, that the recommended dietary allowance, particularly for older adults, is insufficient or inadequate to increase muscle protein synthesis and therefore contribute to maintaining muscle mass in older individuals. And more importantly, perhaps, that the source of the additional protein being consumed is a really important consideration. And as I may not have mentioned, but we also took a look at some of the acute anabolic signaling events. So these are some of the protein pathways in the muscle that are related to this muscle building response. And you can see here that quite nicely, the mTORC1, which is known as a master regulator of protein synthesis, RPS6, which is downstream of that in the protein signaling pathway, and a couple of the other protein signaling markers. There were no differences between the sources here, but providing more protein helps to overcome some of the blunted protein signaling events that we often see in older individuals. Now, what I'm hoping that you'll take away from this is that manipulating dietary protein can be a really, really useful and important strategy to help increase muscle building in older adults. I think this highlights quite nicely that current recommendations are insufficient to increase muscle protein synthesis and subsequently increase muscle mass maintenance as individuals get closer to the end of their lives. And finally, that the source of the protein is a really important consideration when you are increasing the protein intake of these older individuals. And in this case, it shows quite nicely that pea protein is equivalent in its ability to stimulate muscle building when compared with whey protein, and both of which are superior to collagen protein. So I think that's quite a nice message for pea protein enthusiasts. And I'd like to wrap up my presentation there, but if you have any questions, I'd be more than willing to answer them in the chat afterwards. Thank you very much for your attention.
Thanks so much, James. That's very interesting, and it's a exciting conclusion for the pulse sector. at least the comparability of pea protein to whey. So we're going to transition now. I'm going to introduce Dr. Jacob Smith. So he is an innovation advisor with RTI International, and RTI has conducted an in-depth assessment of some of the patent activity that has been leveraging pea protein in new innovations, and he'll walk through some of the key takeaways specific to the food innovation landscape. So I'll take it away, Jacob.
Fantastic. Thank you, Janelle. And great job on the previous presentation. I think those key takeaways are fantastic. And hopefully this presentation will build on that to help give all of the attendees here today some inspiration to think about how to continue to push the boundaries as you're thinking about how to incorporate pea protein into new products. So just before we begin, I will give a brief intro to who I am and the company I work for. So I work with RTI International. We're a mission-driven, independent research institute. And basically, across a wide range of different areas, we help our clients solve problems that are aligned with our mission. To give a brief overview, we have quite a few different focus areas. We're a relatively large organization, so you can see here a brief list of those. And across those focus areas, we offer a variety of different services and solutions that range all the way from the type of desktop research and investigation that was associated with this project, all the way through to rigorous lab studies and even scaling and up new processes and innovations in our labs. So to dive into this particular project, we took a very broad view of the pea protein patent literature. So at the highest level of this framework, we looked at over 61,000 global patents with the pea keyword. And we were able to determine out of that set, there were about 5,400 that were really pea protein related. We worked together with the Pulse Canada team and some data scientists on our side to help filter that data set and really hone in on 200 of the patents that have been published or filed since 1999 through 2025. That's just kind of the time frame in which we did this project, to get to a set that we're going to discuss today, which is 139 or so of those 200 patents that are related to food. So if you take a high level glance at the patent set, what you'll see is that the innovation in this area spans the entire ecosystem. There are contributions from food and beverage manufacturers, ingredient processors, bio and ag tech companies, universities, and startups. And you'll note that the innovation has really been accelerating. 90% of the patents out of this specific set were filed since 2020. And when you look at the jurisdictions of these patents filing, you'll see that there's a lot of innovation happening in China. The United States follows China in terms of patent activity. And then France also has quite a bit of patent activity. And the rest of the innovation is really happening globally. There are numerous countries in this data set that all had relevant information as it relates to food and beverage and pea protein. So one of the things that I want to focus on today, and is going to be part of the framework we use as we walk through this, are these innovation levers. And we grouped this for this presentation into 6 main categories. How are innovators getting pea protein into products to provide the functionality that they need? So blending and formulation, fractionation and separation, physical treatment or thermomechanical treatment, enzyme treatment, chemical treatment, and fermentation are all approaches that we've seen across the patent set that are being used in order to further integrate pea protein into products where the native properties are not necessarily meeting the challenges that they have as they're formulating. And when you really zoom in on the food and beverage industry specifically, you can kind of see a breakdown here on the left of where the majority of that activity is happening. So there's some general functional ingredient related patents that may mention an application. Plant-based dairy is a big space. Plant-based meat is another space. General nutrition, clean grape flavor ingredients, encapsulants, and quite a few other categories that showed up. So today we won't be talking about nutraceutical and pharmaceutical applications, but those are included in the full data set. What we're really going to focus on today are some specific areas that I believe are of high interest to the attendees today. So we're going to look at beverages, cheese, yogurt, meat analogs, nutritional products, and sauces and spreads. So the next few slides are going to be the application-specific insights, and they are kind of eye charts, but I'll help you navigate these slides so you can focus on what's most important to you as we walk through these. So what you'll see on these slides is a big box of key takeaways and noteworthy innovations. These are things that are directly coming from particular patents within the set that are relevant to this category. If you're interested in the types of products that were existing in that category, you can see those in the box here, the key challenges that the patents were seeking to solve here, and then a list of the levers, the different specific approaches, and kind of the evidence level associated with the different approaches and levers that are being used. So a trend means that there was a reasonable amount, 5 or so plus patents that were leveraging that particular lever. A signal is maybe a few patents, and a data point is exactly that. It's a data point. So we'll walk through the different applications, and I'll just hit the high points so you can kind of navigate where you want to focus on these slides. So in the beverage area application space, what we're seeing is, hydrolyzed pea protein is becoming kind of a signal and may transition to a trend, and may already be since we finished this product. We're seeing a lot of activity. Pea protein hydrolysates have lower molecular weights, higher solubility to solve some of those challenges that you have in beverage formulation. We're seeing a lot of activity in coffee that you can see here for coffee creamers and ready-to-drink coffee drinks, where pea proteins, either native capabilities or more functional capabilities that are being drawn out by these levers, are helping to achieve some of the particular goals like foaming and stability that you see. We're seeing things that have historically been applied in the dairy and beverage industry start to be applied to pea protein solutions like high pressure homogenization. And we're starting to see some unique combinations of technologies like enzyme inhibitors along with thermomechanical treatments in order to inhibit some of the enzymes that cause the off flavors that can be a problem in these applications for beverages. When you look at cheese alternatives, really one of the key things that stands out here is that the blending aspect of this particular class is key. So one of the things that many of the patents mention is that there's a pea protein combined in combination with a starch in order to combat the rigid gels that pea proteins can form on their own. It helps you get to a stretchable cheese that might have properties, like mobility and melt. Some of the patents are taking that a step further, where in conjunction or in tandem with the starch, they're throwing proteases in that can help increase protein mobility to give you more of those functional properties that you're seeking. On the other side of that, we're seeing cases where enzymes, transglutaminase, are actually being used to cross-link different components to give you a more structure that you're looking for in these more solid products. We've seen some interesting developments for proprietary ingredients that are fermented pea proteins that have different flavor claims associated with them. Things that are claiming that when you blend, for instance, pea protein with a oat base, you can get cheese that browns for your fried halloumi sandwich. And in very few cases across this whole set, we're starting to see some instances where chemical modification is being used to get these ingredients to be formulated into these applications. But a lot of that activity is more on the nutraceutical and pharmaceutical side. For yogurt, there was a relatively few patents that were associated with with yogurt in this particular data set, but we are seeing some unique call outs to particular blends that address things like astringency. So you can see the rapeseed blending bullet at the top of this chart. Thermal treatment being used to create gels for yogurt texture and structure. Enzymatic hydrolysis being used in ways that's maybe outside of what you would normally think. So it can be used to help break down the starches in concentrates in order to help feed the cultures that are actually producing the lactic acid that leads to those yogurts. We're seeing some activity across dairy generally on microparticulation. So again, high pressure homogenization being used to get these particles small enough that you don't have any issues with them coming out of solution as you run further processing on them. And one of the key things I think that across this data set that stands out, but was something particularly in yogurt, is the pea protein that you select can have a big impact on the actual functional properties of your product. So, there are particular brands of pea protein concentrates and isolates that are touted to have particular properties, and you can consider those as you start to formulate in challenging applications like this. For meat analogs, really the two key things here are blending and physical treatment. So blending with other things that help you combat some of the inherent disadvantages of working with plant-based substrates, at the same time as using processing technologies that help you get to those functional characteristics that you're looking for, like the fibrous texture, so on and so forth. So a lot of the IP in this space really gets into the details of actual extrusion processes, how to make that equipment work better to get a meat product out using pea protein that is closer to what consumers are expecting as they start to try these new products. Seeing lots of different blends here across this set, whey as a hybrid, rapeseed again, fava beans, so other pulses and legumes being used here. And some more innovative things that are starting to emerge are applications of nanoparticles being explored for fat mimicry, so finding ways to create things that can be emulsions that give you that oil encapsulation that you might be used to experiencing in the animal meats. And one of the other interesting things is, particularly in Asia, we're starting to see some activity on 3D printing using pea protein, along with other proprietary blends of ingredients that are mentioned in those patents to give you structured, seafood alternatives. On the nutrition application front, really one of the key takeaways here is that pea protein inherently has this kind of clean label hypoallergenic property that makes it a great potential addition to nutrition products. So we're seeing that come out as a kind of a key differentiator that's mentioned in many of the patents that exist in this space. We're also seeing that, similar to beverages, because beverages might exist in this nutrition applications category, hydrolyzed pea proteins, pea protein hydrolysates can help you get where you want to go to have the types of beverage properties that you're looking for, more solubility, less off flavors in cases. It's really a good source of protein. The metrics for pea protein versus some of the others are quite good, but folks are also exploring, combining pea protein with others in order to help meet whatever criteria in whatever country they're formulating in, so that they can make claims based on, being a complete protein product in cases where maybe they're using a version of pea protein that might not inherently meet that standard. We're seeing other cases where, peas being combined with fibers in order to enhance digestibility, and some cases where the off flavors are being addressed through some unique processing methods, heating slurries in order to reduce saponin content, for instance, to address some of the bitterness that you might have if you don't actually do that step of a process. And the last one here is sauces and spreads. So this category was less prevalent in the data set, but the activity is one of the spaces where I think even, you know, kind of what Janelle was explaining earlier, we're starting to see that, you know, consumers are aware and would be interested in seeing products here. And the landscape is a little bit different here. We're starting to see some carryover from some of the categories that we're not covering here today, like egg replacements, become a key component of this. So when you look at the sauces and spread space, we're seeing a lot of innovation with pea albumin specifically. So using that component of pea protein to help with stability. And it has properties that make it great at low pHs, which is a good property to have for sauces and spreads. You know, in other cases, you're combining it with some of the traditional ingredients to get to the textures that you're looking for. So things like gel and gum to get to the emulsification, gelling, and foaming properties that better match what eggs might have in a traditional sauce or spread, or whatever other series of ingredients you might be using. Hydrolyzed pea protein is kind of a multifunctional thing we're starting to see. So in addition to the improvements in solubility and maybe flavor, we're also seeing it pop up in this case as a ingredient that can help produce a glossy texture for oil and water emulsions. And for some of the fermented sauces, it can actually be used as a fermentation substrate. So in contrast to the soy-based products. So we've gone through a lot of content today. I hope you all were able to kind of hone in on the parts of the slides that were most of interest to you and the work that you're performing. All of the information that was covered here today is available in the patent set that Janelle and her team has, and believe is in the Pea Protein Resource Hub. Janelle, you can correct me after this and direct folks to the right place. But hopefully this was a catalyst to get you to go look more in depth at that material and see what deep technical details live within that information that might be helpful to the applications that you're working on. So just to summarize, the kind of 6 key areas where we're seeing levers being used to help enhance the functionality to get more pea protein into all of these product categories. Blending and formulation is one that appears in almost, probably a 75+% of these patents. It helps unlock functionality that pea protein might not be able to achieve on its own. Enzyme treatment, hydrolysis is one that folks are pretty familiar with. But we're also seeing proteases being used to help increase mobility for cheeses, transglutaminase for cross-linking to help do the opposite and bring firmer texture to foods. And in some cases, there's actually some more complex processes that are included in that off-flavor set of patents that are using hydrolysis plus fermentation for salt enhancement and salt-reduced foods. The physical treatment front, heat and pressure are unlocking a lot of new functionality and stability in pea protein-based products. On the fermentation front, we're also seeing not just the traditional fermentation processes that show up in some of these dairy foods, but we're seeing things like shiitake mycelium come up, yeast fermentation, because yeast can convert volatile molecules like some of those aldehydes that might show up as off flavors into maybe a fruity flavor or something of that nature, which could be interesting for beverage applications or even food applications. Things like koji and lab and hydrolysis, which we covered above. Then the last 2 categories, fractionation and separation. Pea protein fractions inherently have different functional properties. Albumin is one that's emerging as an emulsion specialist in some cases, but we're also seeing ultrafiltered pea protein show up to have foaming and good foaming and emulsification properties and solubility properties. P globulins that have more minerals than the albumin fraction that can help with nutritional claims and products. On the chemical treatment side, this is a side, an area that we didn't see much in this patent set. It's more prevalent in the nutraceutical and pharmaceutical area, but just to say that there is activity there and there are solutions that folks have felt like it was worth the investment to protect in the context of this innovation ecosystem. At the bottom, you'll see some of the emerging levers and applications here where maybe there was a one-off example, or in the case of encapsulation, something that's much more prevalent outside of the food space, but is something that you could consider as you start to formulate new products. And with that, I will wrap up and turn it back over to you, Janelle.
Great. Thanks, Jacob. That's a great job synthesizing a very large collection of data. So thanks for that. And I'll just mention there is all of that information, all of the individual patents that were highlighted there are available in the form of a report that you can access in the hub. And there is so much more that we just didn't have the time to cover here today. So in addition to different food applications, there's also non-food and other interesting areas that might be relevant. Before we wrap up here, I'm just going to close things off. I have one presentation that's providing an overview of a recent research project that we collaborated on with several different institutions here in Canada, all related to understanding variability that exists in pea protein. Within my position here at Pulse Canada, we work very closely with R&D staff from ingredient processors all the way through to new product developers at food industry associations. Ultimately, what we're trying to achieve or understand through research and technical initiatives are how can we advance utilization and how does pea protein perform across different applications, and how comparable is it to some of the baseline industry standards in the plant protein and just protein space in general. So whey and soy, and compared to innovative forms of protein. So just in the pulse sector, we're seeing a growth in fava bean as an example. One of the challenges that we have is that the performance of pea protein as a category is affected by several different factors. So this ranges anywhere from the farm all the way through to the food formulation. So it's very difficult for us to be able to conclude and just say pea protein in general does this. There are differences in across varietals, how they react to different growing conditions that affect the protein composition, the seed structural components that can change how these ingredients process and can be used, different types of proteins, so just generically isolates versus concentrates, but applied processing conditions at the ingredient manufacturing level play a very significant role. And Jacob's presentation highlighted a whole number of different types of levers that were getting pulled that companies are leveraging to develop innovative solutions and very functional ingredients, but that can be a little bit confusing when you're trying to navigate the landscape when it comes to sourcing a pea protein, as well as the testing matrix. So when we're talking about food formulation, what other ingredients are present can affect the performance, salinity, pH, etc. So there's a lot of factors. I've pulled a couple of examples across the literature just to highlight the variability that does exist. So number one was that kind of the genetics. So this is a table that was synthesized in a review that I've referenced below, looking at differences in proximate composition or functional characteristics across different studies that isolated pea protein using wet extraction methods and compared multiple different varieties or cultivars. So you can just see here how significant of an effect just the raw material source can have in altering not only the protein content, but also its solubility and its functional attributes that would relate to how you might leverage it across different applications. Looking at the effect of processing conditions. So here are just a couple of different examples across air classified material, isolate material, as well as looking at some of those functionalized ingredients that might have a supplemental process applied to it. Here's where we really see a significant impact. So you're not only affecting the yield by looking at differences in processing technologies, Composition can change, digestibility and the structure by means of structural unfolding, hydrolysis, cross-linking of proteins, and aggregation can occur. So there's a very significant impact in many factors about that protein itself that change how it's performed. And oftentimes what this can do is make something very functional, but when you're comparing across suppliers, it might be different because you're seeing a significant difference from company A to company B, and oftentimes that can be due to those processing conditions that are applied. Moving along to differences in analytical methodology. So this is really relevant when we're looking to literature to try to understand functional advantages of pea protein, looking at ingredient characterization and trying to map that to its performance in food system. Is that particularly when we're looking at functional properties, there are no standard methods that exist to ensure replicable results or comparable results across studies. And also, when you get into the commercial sector, differences in labs. So, if you're trying to compare yourself as a food supplier, your own lab, to a supplier or to a third party lab that you've contracted out for testing, there are several different methods that are in place. And even in one case where potentially the same reference method is being used, we see a significant number of companies that are using modifications. So, this is just a survey that Pulse Canada conducted in 2022 where we found for any one individual reference method in the functional landscape, 20 to 40% of companies were leveraging modifications. I've just highlighted the degree to which that can impact results. So on the right-hand side, you're seeing oil absorption capacity for protein ingredients, where the two bars are showing differences according to methods where the actual conditions that were altered are highlighted in the text below, but the value itself can change quite significantly. The other point I wanted to highlight of this figure that I think is important when we're looking to literature and published research and trying to draw conclusions to practice in the commercial landscape is how significantly laboratory produced ingredients can differ from commercial ingredients. So on the left hand side, PPC1, that was one that was derived in the laboratory setting, and PPC2 was derived from a commercial processor. So it's difficult to always compare lab versus commercial ingredients and try to understand their performance, given that impact of process and how laboratory to pilot to scale up doesn't always translate very nicely. So overall, how we were trying to think about how can we better understand this is Pulse Canada partnered with the NRC and Canada Grain Commission here in Canada to look at a project where we could assess commercial ingredients, understand variability, and just characterize the degree to which these ingredients vary, and then see if we could start to draw any conclusions to understand if we can make statements around how does pea protein differ from fava beans, how does it differ from lentil, and then we also included two soy protein isolate controls just to serve kind of as background for some of the data that was collected here. Looking at the proximate composition, so we saw very obvious differences across isolates and concentrates just in terms of protein content. You can also see that the concentrate category had significantly higher levels of dietary fiber, whereas fava bean protein had a little bit higher protein content than some of the other pulse types, just given that the seed itself has intrinsically higher natural levels of protein compared to a pea or a lentil source of protein. I think an interesting call out here is on the fat content for isolates. That's where we saw a lot of variability across suppliers, where some companies are leveraging a defatting step and others might not be. But that ranged anywhere from 0 to 5%. And the highest number of samples that were collected were in that pea protein isolate category. Looking at the protein quality results. So here was really interesting where we saw generally kind of confirmed what we already knew from literature, that the isolation process just through unfolding the proteins might make them a little bit more digestible. So having a higher in vitro protein digestibility for kind of those top pea protein isolate samples here compared to the pea protein concentrate samples. I think one of the interesting callouts here when you're looking at the amino acid score is, given the conditions that are applied, you might selectively retain or exclude individual proteins found within pea. So the albumin fraction is a good example that has a relatively higher proportion of sulfur-containing amino acids, and that had a pretty significant impact on the amino acid score and resulting in vitro PDCAS when calculated. So the isolate category in particular really showed a lot of variability in terms of the protein quality scores, where this was less apparent. Even though variability did exist still, it was a little bit less drastic across the pea protein concentrate category. Taking a look at mineral variability, here we saw differences, what we hypothesized to be due to the use of different salts during the wet extraction process, where isolates demonstrated either higher concentrations of calcium or sodium due to the use of salts that can help to facilitate extraction or alter the functionality. We saw that magnesium and calcium had higher concentrations in the concentrate samples as opposed to the isolates, and that iron levels were a little bit higher in the isolate fractions for every one of the pulse types that were analyzed, given that we saw accumulation of the ferritin protein, which contains iron. Looking at the functional properties, so here's just highlighting some of the physical properties. So just given that the wet extraction process really significantly impacts the structure and the conformation of proteins, the spray drying process itself is causing, in some cases, full denaturation of the pea proteins, depending on the supplier. This had an impact on differences in properties. So surface hydrophobicity was higher in isolates because they're unfolding and exposing more hydrophobic sites. We also see just that since there's a higher concentration of protein itself, there's just a greater relative concentration of nonpolar amino acids, which might have a higher affinity to certain units and charges. Zeta potential was a little bit more negative charges for protein isolates, as well as particle size was higher in some of those isolate fractions, largely due to agglomeration that might occur during drying processes. So this is a very big graph, but overall what this figure here is trying to show is that as you get blue, values are seen to be higher, and as you get more towards the green, values are shown to be lower for several different attributes that we measured in the functional landscape across a suite of different chemical environments as well. So looking at salt and pH conditions, where here we're really trying to understand, are there differences that we can say between concentrates, between isolates, and can we start to see differences across pulse types? So first off, I just wanted to highlight the differences that were observed between the concentrate and isolate category. I've highlighted what was most significant in red boxes here. So given that there is that partial denaturation that occurs in the isolate process, we see a little bit of loss of functionality than what would otherwise be retained when you still have access to that native protein structure, as is in the case in air classified samples. Where solubility was a little bit higher in concentrates, we saw higher water holding capacity in lower water holding capacity in concentrates, higher in isolates, given that kind of unfolding, and higher oil absorption capacity for concentrates. We also saw that there was a lower concentration required to form a gel, looking at the least gelation capacity in concentrates. That also could be partially due to the presence of carbohydrate components, particularly starch, which gel under the conditions that were imposed. But you can start to see that there were some pretty clear trends in terms of how concentrates versus isolates might perform in food systems. When it comes to understanding differences across pulse types, it was a little bit more difficult to say just looking at the data. So that's where we leveraged a more statistical analysis here, so MLFA. looking here, how you can interpret this is that where we have clustering of individual samples, that's where we can understand that they are more like each other. And when we have distinctions and different groups of clusterings, then they might be statistically different from another. So we can understand how different groups within this population are differentiated from one another based on how they cluster in that above chart. And what's driving the differences in these different cluster groups is related to the placement on the bottom here. So you can see we evaluated all of the functional attributes that were analyzed. Here in the first two figures, what I just like to call out is similar to what we already showed. We saw very distinct clustering of isolates versus concentrates. When you start to dive in to understand within each category, what are the differences between pea, between soy, between fava, it was a little bit more conflicting. So across the isolate category here, in the middle chart and on the left-hand side, there wasn't a clear clustering or separation of any individual crop type. So you can see soy is found kind of all throughout the blend here, lentils thrown in the mix, pea and fava are all blended together. In addition to on this left-hand side, versus when we take a look and zoom in on the concentrate group, we did see very distinct clustering of pulse types. So what this tells us is that the process of producing isolates is very significant, and it might in fact outweigh or just have a much more significant impact on the resulting functional properties for some of these ingredients, and kind of minimize any of those intrinsic crop specific differences. However, we were able to kind of distinguish those based on certain functional parameters when we looked at the concentrate category. So here you're retaining that native protein structure. You might be a little bit more susceptible to genetic and environmental influences, but you can see clear distinction between some of those crop types. And here's something that we could look to understand a little bit more through future research or future projects. All that to say, I just wanted to call out that it's I understanding that it can be maybe a little bit confusing to navigate the landscape when you're looking to source a pea protein, but a lot of this variability exists, and it introduces a really significant opportunity to work with the suppliers of the ingredients to get a very intentionally functionalized ingredient that will work for a particular end use application. And even though one might not work for one food product category, it could work very well for another. So this is just highlighting the difference in just solubility for pea protein in water as it was received from the supplier, where maybe company 2 and company 9 might be a little bit better suited for a beverage style application or something that needs to be completely solubilized in water. Some of the other ones might be better suited for something like a bakery application where it doesn't need to be fully submersed in an aqueous solution. So here, the supplier and the ingredient manufacturers themselves have a lot of understanding of their own ingredient and are really going to be able to help draw the conclusions and help you navigate where it might be a good fit within the food landscape. So in conclusion here for this study, even though we did see that variability, we think of that as an opportunity to really tailor the functionality of these ingredients so that they're fit for the intended end use application. Or you could look at it the reverse way to look at application specific optimization. And because there's that variability, then that really opens the doors to look at pea protein across a very broad range of end use categories. And we saw that in the patent literature, we saw that in the innovation data, that pea protein is really flexible and can be used across a whole range of different samples or different end categories. So here, the results of the nutrition study are published. You can access it with this QR code. I think there's also a link to it in the hub. And then the functionality data set is just in press. It's been accepted in Sustainable Food Protein, so that should be available shortly. Really quickly before we wrap up, we just wanted to briefly highlight one particular application looking at pea protein concentrate, just as an example of the potential in a specific food category. So in this project, we partnered with Red River College, the Prairie Research Kitchen that they have there, in order to assess pea protein concentrates potential at substituting eggs in formulations. So you're looking here at the formulation for a Belgian style waffle where pea protein was substituted on a 1-for-1 basis in treatment 1, where we were maintaining the protein content equivalency to a full egg formulation. And then treatment 2, it was a reduced concentration of pea protein in water. So you can see that overall it was quite a successful substitution. So pea protein has moisture binding properties, it has emulsion properties, browning, that are able to contribute to a successful iteration of waffles that were egg-free. We did see increase in batter viscosity. Depending on the pea protein concentration, we saw differences in the degree of browning. And even though there was a slight detection of a toasted or vegetal note, overall, the chefs that were developing these formulations thought that that was something that could be easily masked just by putting maple syrup or berries and how you would normally consume a waffle. It's traditionally not on its own as it was tried in this project. Sponge cake. So here is an area where it didn't necessarily work very well. So here in sponge cake applications, you're really relying on that foaming capacity and stabilization to maintain that aerated structure in the application. And here we saw that the batter was much more dense and was more susceptible to collapsing and didn't get that same volume, height, and airiness as the control formulation. So not necessarily an application that was well suited. Looking at pea protein concentrate as a full substitution, here we could look at maybe just looking at binding properties as partial substitution, or the chef suggested that it could have potential in cake applications where you don't require as much aeration. So looking at things like pound cakes or brownies where it's not as necessary to the structure. Cookies here, where is another one where the chefs considered this to be relatively successful. So across different treatments, looking at pea protein, looking at a pea protein hydrocolloid blend, or blended with the starch-rich flour from air classification. Here, overall, most of the treatments were considered acceptable, had good sensory characteristics, a nice crackly top, and maintained chewiness, and just saw differences in terms of the thickness and spread between different trials. And again, the dough was a little bit, it had more tack, a little bit stronger. So it changed some of the dough structure, but overall, the chefs that were working with this thought it was workable and a successful substitution. And then lastly, a Danish pastry application. So here in this application, eggs aren't necessarily contributing much structurally. You're really relying on the butter pack to create that flaky layer and create the texture. However, you do leverage eggs for some of the browning characteristics, and we saw very successful color development in these applications. And one of the notes from the chefs here is that the dough itself was slightly tougher, and they indicated that this might be actually beneficial to commercial processing, where it might be able to be a little bit more resistant to harsher conditions during mixing and the sheeting process itself. But overall, very, very acceptable, very favorable sensory properties and finished products that were very suited to substitute eggs here. So that is a really quick snapshot of that study. You can find more details again in the hub, but I think with that, we will start responding to some of the questions in the audience here. So I have everyone up on stage. I'm going to... So there are a couple questions here about the consumer data that was presented, and I'll maybe just, for the sake of time, I'll point audience members to the hub where you can see a comprehensive report on the consumer study that we had done. It was focused on US consumers, but there's a lot more details than kind of the couple slides that I touched on. Here we have a question for James. One of the questions here was specifically related to the leucine content and BCAA measured, and we're just asking if it was measured in the diets for the groups that were fed in the trials.
Yeah, absolutely. And I think the two questions that I got were due to the amino acid profile. So there's another one which kind of leans to the same kind of angle. Yes, absolutely. There are stark differences in the amino acid profiles between whey, pea, and collagen. And I think most importantly, when it comes to muscle building, is the leucine content rather than the other branch chain amino acids. Whey per serving has about 2.7 grams. And given that we fed this with their breakfast meal and their lunchtime meals, 2.7 grams of leucine plus the little bit of protein contained in their other meals generally gets them past this kind of threshold of 3 grams of leucine, which is required to turn on the muscle building processes. Pea protein, in our case, had around 2 grams. So, probably when you combine that with breakfast, was sufficient to turn on those muscle building processes. But collagen protein is way down there in like less than a gram per serving. So, I think, yes, essential amino acids, but particularly the leucine content is really important for these processes.
That's great. Thanks, James. So I see one question here on heavy metals. So we have monitored heavy metals in both raw seed and ingredient commercial materials. So that's something that our industry is consistently monitoring to ensure that they are compliant with any sort of regional jurisdiction or state level regulations. One of the strategies that our industry is looking at to minimize some of the presence of heavy metals is we're starting to collect data on genetic and environmental influences, and we have seen a significant impact of variety in terms of preferential accumulation of specific heavy metals, and then regionally there's differences in soil concentration. So that's just a potential strategy and maybe something that our industry we're already looking at to try to look at how to mitigate any concerns. But for the most part, everyone in the sector is monitoring levels for that and ensuring that they are compliant with any form of regulation or customer specifications. Another question here on standardized methods of analysis. So we've been doing a little bit of work on particle size analysis, specifically in collaboration with the University of Saskatchewan, where pulse ingredients have a little bit of a different manner in which you could interpret the particle size when you're comparing it to something like wheat flour, which is very well understood. So there's a couple interesting publications there that I can point you to. And that's something that we're actively going to be looking at, I'd say, in future work. Happy to kind of talk about that maybe at a later time if you'd want to shoot me an email. James, there's another question here for you that just came in on MPS in 20 to 40-year-old adults. I'm not sure if you're able to tackle that one there.
Of course, I don't have the data myself, but there are labs across the world that have investigated muscle protein synthesis in younger adults. Generally, pea protein fares pretty well in comparison to whey protein. And even the longer term exercise training studies where they've fed them over 10, 12 weeks and looked at muscle growth as opposed to this acute phase after feeding, they're equivalent. So, what I think that means quite nicely is that plant-based protein sources, pulse sources of protein can be as effective as popular animal-based protein sources when consumed alongside resistance exercise to promote muscle growth over time. So, yeah, there are some data. I can't take responsibility for that, though. Unfortunately, it wasn't my study, which is a shame because it's cool work.
Thanks. There's one question here just asking about more looking at the scientific literature and doing a similar type of analysis to what Jacob had presented in the patent landscape. And I'm just like saying the same thing over and over again, but the resource hub there is one document that we pulled together that's called Pea Protein 101. That one provides a pretty comprehensive overview of application related innovations. So just looking at different techniques for formulating, for process adjustments, and trying to highlight distinct functionality benefits of pea protein across various food applications. So I'll point you there. There's also several different review articles that have been published over the years. So we're always happy, or just I'm always happy for anyone who is interested just to take a look and dive into the scientific literature. We're always trying to kind of synthesize that, pull together white papers and resources, just understanding that not everyone has time to kind of really do a deep dig in of all of the published works. So just looking at a couple of the other ones that are coming in here. There's a question about how suppliers or end users could work towards achieving more uniform properties of pulse ingredients. I think to the previous question, what we see as a lot of potential is aligning just on some of the language and the terminology that's being used in the industry. So we've worked with several of the North American manufacturers over the years to come up with a definition set for pulse ingredients so that everyone can be working and using the same language when they're talking about these ingredients. So that's something that we're working on, kind of synthesizing and publishing the results of this initiative very shortly. I think the other piece to that is really going to be in industry methods and standards, where if everyone can kind of evaluate these ingredients the same, then it can level the playing field a bit more and facilitate ease of comparisons. And then if we can drive that a little bit further and then establish methods that are well suited to predict the performance or that are tailored for specific applications, so then you can then take that test and link it to an end use application or end use suitability. I think that that's something that we can get towards, where you could then take a handful of suppliers. If it's a quick, easy, industry friendly test, that would be a way that you could kind of ease and minimize some of that variability, or at least help to navigate it a little bit more as an industry. It's my opinion here. Um, a question on looking at predicting variability or the application based on a particular batch from a supplier. I would say that kind of aligns with what I was saying previously. If we can get to a point where there are methods and standards that exist, or methods more in particular that are well suited to predicting application performance, I think that that's something that could help get there, where you can receive a raw ingredient and then determine whether or not it's suitable for a particular application. Seeing that we're a couple minutes over time, I might say if you have any follow-up questions, you can feel free to reach out to us at Pulse Canada. So my email is jcarlin@pulsecanada.com. I'm happy to connect you or follow up with the contact information for any of our panelists here today. So Dr. McKendry and Dr. Smith as well. But overall, thank you both so much. Very, very insightful presentations, and there's a lot of information that we tried to squish into this little hour 15 here, but I really appreciate your time, and thanks to everyone for hopping on and staying tuned here. So any questions, please follow up, but very happy to have you. I think there's a quick video that our team pulled together to highlight the Pea Protein Resource Hub. So I've mentioned it several times here, but just to highlight some of the specific things that are included is a mini course which was pulled together on all of the different scientific research for addressing flavor challenges in pea ingredients. There's a pea quality calculator, which is leveraging data sets for amino acid and protein quality content that you can look at protein and fiber contributions, looking at different blends, consumer research and messaging guides. There's a lot of different resources. I talked about many of them here today. So at the sake of just saying the same thing over and over again, just check it out and see what's in there. But thanks everyone, and wishing everyone a good rest of the day.